G'day, I'm Dave Cheney, and crikey, it's go time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. We are back for another episode of Go Time. Today on the show, we have myself, Eric St. Martin. Brian Kettleson is also on the show today.
Hello.
And Carlicia Campos.
Hi, everybody.
And our special guest today, although he needs very little introduction, is Dave Cheney. Say hello, Dave. Why don't you give everybody kind of a brief introduction?
Hello there. Hi, my name's David. I am a Go enthusiast from Sydney, Australia. I've been involved in Go for many, many years, and I just love the opportunity to be involved with the language and get involved so early to be involved in something I'm so passionate about. So, hello, everyone.
Now, it's kind of amusing having you introduce yourself. One of the things that we found at GopherCon just a month or so ago was that nearly everyone that we talked to learned Go from your blog. There, out of the 1,500 people that were there, 1,499 of them listed your blog as one of the resources they use to use Go. So it is kind of embarrassing to introduce you, but we feel it's necessary.
Yeah, it was great to meet so many people at GopherCon, and it was really touching the way that everyone was like, "Oh, I love to read your blog." It was really touching because 5 years ago I never started out to be an author or a blogger or a public speaker. It was just the way that, like every good engineer, you think, "Oh, I've answered this problem so many times. I can solve this by just writing it down once, and then I can give people the URL." And that's kind of how I got started.
So a question on that: did Go encourage you to find your voice, or did just becoming a better engineer encourage you to find that voice?
I don't. It's kind of a question: does the tail wag the dog, or does the dog wag the tail? Certainly. So I joined Canonical. Would have been about 5 years ago, about 4 or 5 years ago, and we were encouraged to communicate on IRC all the time, and so it was a great opportunity to moonlight in the the IRC channel for Go, and I at the time, like, this was Go 1.1.0 was just barely out, and there were so many questions people have, and they would kind of come into the channel all the time and ask the same question, and so I would as I said, try to solve this problem by just writing it down, and I give people URLs. And then around the same time, so Go had supported ARM, and I knew this, and I found a really cheap ARM box in Australia. And one of the magical things about Australia is that we don't have access to Raspberry Pis and things like that. It's always hard to get equipment. And so when I found this, I was like, can I install Go on it? And I could, and that became the very first builder. And I was so excited about it. I wanted to tell people about, hey, you can run Go on this kind of hacked up NAS. And that was one of the first things I wrote on my blog. And then it just went from there.
In addition to all the blog writing, you've also contributed quite a bit to Go.
Yeah. So as I said in my introduction, it was kind of like this opportunity to get involved at the ground floor. All you needed to be involved was spare time, and it's just snowballed since then. That kind of see a need, fill a need kind of thing.
For years, you hosted the unofficial builds for the ARM platforms on your website, and I think it was not too far in the past when Go started making the build dashboard and actually having builders that were hosted in-house. But I think for the longest time, all of us that used ARM boards with Go were downloading Go directly from you, which was awesome, and we all appreciate it. Our Raspberry Pis definitely are thankful for that.
Yeah, so ARM, I really think ARM is really special. I know Intel rules most of the server world, but ARM has a really special place. It's so simple. It's such a beautifully clean operating instruction set rather than the Intel mess. And so I appreciate Go for being simple and minimal, I really appreciated ARM for being all the same things. the story for how to build and build an ARM distribution, and mainly a lot of the magic about ARM machines is they're usually pretty weak, especially the ARM 5 ones. So a lot of people didn't have the opportunity to build Go. Cross-compiling used to be quite difficult, as we all know. So that was just something I could do. I reached out to Andrew and said, as long as I put a big warning, not official, unsupported label at the top, are you happy for me to maintain those builds? And he was happy to. But in the last year, we've managed to get real builders using places like Scaleway. I think Scaleway hosts all the Intel builders, so now we have real builders on the dashboard, which means that the Go project can produce a real tarball for everyone to use, which is exactly what I wanted. It's graduated from being from being a side project to being something that's fully supported by the Go team now.
Now, I think the blog post I'm waiting for the most is how does Dave Cheney make more time in a day? Because it's like you have a day job, you contribute to Go, you contribute to proposals for language changes. Recently, you've been traveling a lot, doing talks at a lot of Go conferences, and just how you make time for that is just astonishing.
Yeah, it's a pretty full schedule. The magic of Australia is that it's a day or two in a plane anywhere you want to go. I don't know. I've always been very lucky. Like Canonical were extremely supportive of me working on Go, and they even sponsored some of the time they sponsored me. Like they sponsored Aram and I to work on the first cut of the ARM64 port. So that was great that my day job could become the thing that I love. And you just find time in the weekends and after work, and just integrate it into your life. I'm really lucky that I've been able to do that.
Well, on behalf of all of the people across the world, we all really appreciate the effort that you put into proselytizing Go and teaching everybody and building community. I don't think the Go community would be the way it is now without you. So thank you.
Thanks, Brian.
Yeah, I totally agree with that.
Yeah, I mean, I have to add my name to the list of people who learned a ton from Dave's blog, especially in the early days. I mean, because when Brian and I were starting out in late 2011, early 2012, I mean, there wasn't a lot of content out there.
I feel really lucky and privileged to be able to do that, because it wasn't like it was a space that I could fill up with words. Like there was some great things to say about Go. I was learning a lot about it. I wanted to tell other people about it, and there was just an opportunity. It was like if you'd have met me, as I said, 5 years ago, or 10 years ago, you wouldn't have picked me for any of these things. That I don't know whether I've had to learn them or whether I've been lucky to learn to be a public speaker. Like I haven't done any public speaking since high school. Like I thought when I graduated I can just throw away that bit of my brain. Like I'm never going to need to do public speaking or debating anymore. But had to learn how to do that again. A writer. My father is very impressed by that. He was like, oh, I never. Your writing has improved so much, because like as an engineer leaving high school, I didn't think, what nonfiction writing, who needs that? I just need code.
Well, I think we've spent 14 minutes now on Dave Cheney fanboyism. So why don't we slow down on the ass kissing session for just a minute and talk about some of the really cool things that you've done lately. You gave a great talk at Golang UK last week about solid design. Why don't you tell us a little bit about that?
The meat of that talk, the solid design principles, came out of a presentation I did a couple of months ago in Perth to Dave Thomas's YAO group of conferences, and that talk was to a group of people who didn't really know Go. Like there was a mixed bag of technologists, most of whom were very passionate about functional programming. And so I had an opportunity to take this talk and kind of redo it for a home team crowd, and I wanted to put it inside to make it interesting for the audience. Say, well, why should you care about these things? They're not just being presented in abstract. I want to wrap it in a bigger request for what I see from Go, that if Go is going to be a language which companies invest in, they build products in and use them in their infrastructure, they're going to invest in them for 10, 15, 20 years, then my bigger message was that Go programmers need to start thinking about how programs are designed, like because the alternative is that we'll just become the JavaScript framework of the month and it possibly replaced by something else. But if we think about design and talk, and more importantly, talk about design, develop a language to talk about the design of programs rather than just moving from the next fastest HTTP router to the next one, then then Go has a chance to be a language that people want to use the programs that are written in 10, 15 years.
So Dave's definitely listened to the show because Brian rants about the number of HTTP routers about every episode.
The other talk I gave at Golang UK was about how to write fast Go code. So I might be a little bit hypocritical in dumping on people who are writing HTTP routers. But the bigger picture is that the Go code that we write today has to be maintainable, has to be changeable. It can't just be something which solves today's need. It has to be it needs to be maintainable for the long term, because otherwise maybe in 5 years, people are like, oh, this Go code, it's not maintainable. What are we going to do? And they'll rewrite it in something else, and then continue that kind of search for the next thing. Like to be an investment that the company's going to make for a decade or more. The maintenance of the program is far more important than the initial just sticking the prototype together and seeing how fast it goes.
And there's another aspect of thinking about design. For me, it does take effort. It does take an effort in you learning what good design means. But once you start learning it, it makes coding easier. For example, when I started writing Go, I would think, where do I put things? And I see people asking that all over the place. Where do I put things? Where do I put my models? Where do I put this? Where do I put that? Well, if you take some time and think about how to design your interfaces, how to design your packages, how to organize everything, and if you start thinking about dependencies, that question gets answered automatically, and you end up with good code. So there are multiple layers and multiple reasons for you to think about design, I think.
That's exactly right. And you touched on a really important thing that you just said, good code there, but that's kind of super subjective. What is good code? Well, I like it to look a certain way. I like to have long identifiers. I like to call my receiver this rather than the single letter that we're used to, because that's how I used to do it. And what I was interested in talking about in the UK is what if we had a different language to talk about design that was not so subjective, like I like this and I prefer it to be a certain way, that was more objective. And that's some of the ideas that Martin Solid principles talk about. They're no less opinionated, but they come from a point of saying, I like this because it is easy to modify. I don't like this because there's a lot of coupling with the other types and other packages. We can say it more objectively. And the thing Martin says about the Solid principles is that they're not rules. They're guidelines. Like you can say every now and then, look, I want to be, I should be honest in all my dealings. I should be truthful with all my friends. But sometimes you have to bend the rules, tell a little white lie, those kind of things. And it's, when you talk about design principles, you can say things like, I don't like this because it's quite tightly coupled, but this seems like a reasonable trade-off to achieve our objective. And it's interesting to talk about design using those kind of words rather than things like, I don't like that code should be more beautiful, or I don't like it should be shorter. These are not really actionable for to have in a wider design context, like, because everyone's idea of, well, how short is short, how beautiful is beautiful, becomes just subjective in the subject of arguments.
Right. Some of those things that people point out are more from an aesthetic standpoint, right? And it's like art. What I appreciate is going to always be different from what you appreciate. But I think we can both agree that two highly coupled components are hard to maintain, right? We can collectively agree on that. So yeah, I think talking about this at this objective level makes a lot of sense. And it's one of the reasons why I loved Ruby a lot when I came into the Ruby world, a few years ago was because these were the conversations people were having all the time, or about the law of Demeter and coupling and cohesion and things like that. And I really appreciated that people were talking about making clean abstractions and maintainable code. So I like the idea that we're starting to talk about that in the Go world as well.
Yeah, absolutely. And I think it's critical because if companies are going to invest in the long term, and they have started, like, you have Docker, all the CoreOS products, all the HashiCorp products, Kubernetes, there's an investment, but to make that investment pay off in the future, it can't just be just smashing out code as fast as possible. There has to be some fundamental design so we can change the code in the future as the requirements change.
So my question is, if there's a maturity model for Go as we evolve into a more popular language and a more well adopted language, does that mean we have to go through some ugly growth phases like Gang of Four patterns and enterprise Java beans, or what does our maturity model look like in Go?
Does anybody else want to jump in while I think?
Sure. I think that Gang of Four is probably a little too far, right? I don't think we want to get into that because the language is specifically kind of designed to prevent that, right? Like this whole inheritance chain and things like that. So, but I think that there are some lessons to be learned, right? Like most of those abstractions were built for good reasons, you know, abstracting away, creating clean interfaces and things like that. And I think that we can do that without having to have that many patterns. Like kind of to Dave's point, like there should be kind of objective goals that we're trying to achieve and not necessarily set in stone patterns, I guess would be my take on that.
So I did have a section in the talk which I cut, and because I didn't have enough time, but mainly because I had a lot of pushback on it. So I start the talk by saying, who does code review? Why do you do code review? Someone yelled out to define bad code, and that's really the hook there. And I kind of opened the question like, so the patterns book, does that tell you how to write good code? And my assertion was, perhaps not. Perhaps in the bigger context, they're called patterns because you apply them like a sewing pattern or like a recipe. When you have a particular problem, you could use a set of those solutions if they fit. But I think talking about design and principles, to take Martin's word, are kind of high level notions of what is the goal, not what is the problem I'm solving right now. And if the goal is to make the code maintainable, and by maintainable I mean changeable in the future, a thing like a visitor pattern or an iterator pattern isn't going to give you the vocabulary to talk about that. It's that's just a point solution.
Yeah, I think it also limits the possibilities, right? Like if we always refer to you need to use one of these patterns, I think that it also kind of closes off creativity. But I think that we can generically talk about things like these two components should not be coupled together. And I always mix up the two books. There's another book called Clean Code by Bob Martin as well. And then there's Pragmatic Programmer from Journeyman to Master. Both of those books I really like, and they have a lot of kind of unique ideas in there where they kind of show you like if one type seems to know too much about another type, maybe you have the function in the wrong place and things like that. And we can talk about these at a very, very high level without having to, like you said, go into like, oh, well, this is a visitor pattern or this is a decorator pattern or flywheel or any of the other ones in the Gang of Four book. Like, it's actually kind of interesting. I haven't had to think about the Gang of Four book in a number of years since leaving Java. and that's a good thing too, because I distinctly remember a piece of middleware that I swore somebody went through the book and found a use for every single pattern in the book.
So here's the weird thing about the patterns book. When it was, I guess it was written in the mid to late 80s, probably in the 90s. At the time, people, and I'm kind of gesticulating to the luminaries who write patterns books, thought that it would just be the first of many books. They thought there would be patterns in everything. And, every year there would be, patterns 2005, 2006, like just an endless supply of them. But it actually turned out that the 30 odd of them that are in that book are pretty much all there are. And it's not because DeMarco and his friends Gamma, and sat down and like thought up 30 patterns, and then were like, okay, we've got to do a second edition of the book. They observed them in code that they were looking at. They kind of got it back to front. They looked at this wide body of code and tried to find commonalities, and from there they extrapolated the patterns book. But they could never find more patterns because they're a finite number of them. They're like kind of like a law of nature. You can't invent new laws of nature. They're just there. And so that really kind of all of a sudden, instead of the patterns book being the start of a way that we're going to describe every piece of software design, it just kind of became this one point in time of these couple of dozen kind of observations about software at that time, written in the 80s. And one of the things about my talk, and I was very inspired to do it, ironically in London, because Jim Wyrick's talk from 2007 starts with talking about the Great Fire of London and saying, then when they were going to rebuild London, they had all these proposals for how to rebuild London. And his question, like that he opened his talk with, was, well, looking at all these different plans for how to rebuild London, how do you decide what's a good one? How do you decide, like, we're all not architects in this room, how do you decide which one you like? Like, what is the right design to rebuild London? And again, without a language to describe what is good architectural design any more than what is good software design.
Yeah, that's interesting. I mean, we could say the same about algorithms too, right? There's a lot of clearly defined algorithms that have really good use cases, and we reach for that bag of well-defined algorithms based on need, but sometimes, based on things we know about how things scale and their performance and how clean they are, we also are free to make our own choices, right?
Yeah, to talk about algorithms, what is the meta language that we talk about algorithms? The big O notation. What is the time complexity versus the space complexity? And it's like a linked list has better space complexity, but poorer time complexity. And also in current hardware, it has even poorer time complexity versus just a vector. So the meta language to talk about algorithms are these concepts of time complexity and space complexity. And it's space versus time trade-off.
And I mean, unfortunately, that's a lot more measurable than these concepts we're talking about now with how coupled is something, right? Like that's hard to measure.
Yep. But there's still probably an argument that you could compare like a hash map to just an array of items. For really big hash maps and really big arrays of items, the lookup time is order log n versus order n. But for really small ones, that n is really small. So does it matter? Like
right.
you can't. These are the kind of subtleties of if you were saying, well, we always have to use a hash map because hash maps have faster lookups, is ignoring the fact of it's a HTTP header map. It's maybe only ever going to have 5 things in it. What's the overhead of setting up that hash map, hashing all the items versus just doing a straight linear search through HTTP headers only have like 5 or 6 items in them usually. So those are the kind of design decisions I guess you can talk about with space and time, the big O notation. But so that was the thing that I wanted to get people in the Go community talk about design at a high level rather than just posting on Reddit, hey, I need what's the fastest or the best? Like talk about subjective concerns. What's the fastest web framework? What's the best what's the best HTTP router? These are I wanted to see people start to talk at a higher level and say start thinking about what is the best way to design my application to make it maintainable in the future, make it maintainable and reusable, composable in the future.
Yeah, and I'd love to see more conversations along these lines too, because I mean, I've been developing Go for a number of years, and I still struggle with kind of package layout. Like, at what point do I split things up into separate packages? When do I kind of make sub packages? How we kind of have like IO and then IO util and things like that. And I'm still trying to abstract these patterns from common code bases that I see and come up with my own rules of thumb. So having more conversations like this, more people talking about it, I think is a really good thing because I think a lot of people can learn from this.
Yeah, the standard library is kind of a double-edged sword. Like for like for authors like yourself or anybody who wants to kind of give some advice that won't change next week, the standard library is really good because the Go One guarantee means that it's going to be the same for 5 or 10 years. We can give this advice and no, it won't be out of date soon. But the thing about the Go library is it was some of the most well-reviewed Go code in the world, and it's written by the best Go programmers at the time. It's also some of the oldest Go code, and has some inconsistencies. Like you can look at it and pretty much prove whatever side of the argument you want to make. You'll always find an example in there that supports your whatever argument you want to make. Which is tricky because what is one of the three things that we tell new Go programmers? Go do the tour, go read the language spec, go read the standard library. And it's not as clear a guidance as I think we'd like.
Well, some of the problem with the standard library is that pieces of that code were written before we knew what good Go code design looked like. It evolved with design, and we didn't take the time, we as the Go community didn't take the time to go back and change those things in the standard library for various reasons. And so it is, I agree, it's interesting to see some of the variances in style, especially in the standard lib, based on the age of the code.
Yeah, absolutely.
Yeah, and how you talked about kind of things changing and evolving, it was based on what we knew at the time. I mean, one of those things that you've been also kind of doing talks about and advocating is error handling. And I think before we kind of shift over into that, we should probably break really quick to do kind of a shout out to our sponsors, and then we'll kind of come over and start talking into your error changes.
Okay, cool.
So I'm excited to talk about our new sponsor, Backtrace. Backtrace sponsored our live streaming at GopherCon. So if you were one of the over 10,000 people who tuned in to watch GopherCon on Twitch, you've got Backtrace to thank for it. Software teams are using Backtrace to take the headache and guesswork out of debugging across their frameworks. When your application fails, Backtrace jumps into action, capturing detailed application state, including the complete set of Go routines that are running, the channels and the wait durations on those channels, and lots of good scheduler information too. They analyze all that state and archive it for you so that you can go back and explore the interesting patterns across your errors and try to figure out better ways to make your application work. A lot of big companies are using Backtrace, like Fastly, Limelight Networks, Message System, and AppNexus. So you can check out their website and blog, including details on their premium Go support. And go to backtrace.io/GoTime to start a free trial or request a demo. Yay, Backtrace.
Awesome. So we were just kind of talking about the standard library and evolving it based on new knowledge gained from years of writing code in what is the 1.0 spec. And some of the stuff that we're starting to see, and one of the topics you're primarily advocating, is the way error handling is done. And it seemed like some of the Sentinel error values and kind of just returning up the errors seemed to be good enough as the language was evolving. But I'd like to talk a bit more about kind of your new approach. And you did a talk at GopherCon about it, and you've got your own package to be used to help with error handling. I'd like to talk a bit about that.
Sure. First of all, before I say anything, I need to be very clear that I stand a very small amount above the shoulders of many giants who've done a lot of work before that. The errors package that I wrote is directly influenced by the one that we wrote at Canonical for Juju, which is based on Roger Pepe's work from earlier. Like there is a long lineage of this idea evolving, which is kind of something that I see. I also see in other in other areas in Go, and not to get too distracted. For example, 2 and a bit years ago, Rob Polk wrote about functional options. I thought this was such an amazing pattern that I went and talked about it at .go, mainly because I didn't think people gave Rob's post enough credit. Like I thought it was a brilliant idea, and it just kind of flew under the radar. I talked about it. I got on stage and talked about it at .go. The idea keeps percolating, and the latest evolution of it is in. We see it in gRPC. They use that heavily in the constructors for all the gRPC types, and it's just the the formalization around the naming of options and the way they're gonna call it. So that what I see in the broader perspective there is kind of an evolution of these ideas, which is how it should be. So to talk about errors is two stories that sit side by side. The first story is that I've written a lot of blog posts about how I think error handling should be done. And this is separate from stack traces and things like that. In fact, embarrassingly, I actually wrote the same blog post twice about a month in between. I even gave it the same title. And when it showed up on Reddit, people thought it was a cross post. But the big picture there is that I'm trying to push very heavily this idea that if there's an error returned from your function, in general, and there are always exceptions because especially when you're dealing with the network and retriable things, but in general, you should try to basically say, this error happened. I don't know anything about the details. I just need to go through my cleanup behavior and then give the error back to the caller. It makes the code and the design so much simpler and so much more decoupled to just say, an error happened. I'm going to clean up whatever I was doing in this function, and that can actually, and most times that's for almost nothing because we have nice small functions that are well factored, and then just give the error back to the caller. I don't know what happened. I'm just cleaning up. I'm going to give the error back to the caller. And so that's I've talked about ideas of rather than checking the error matches a particular value, like or the error is a particular type. You should instead try and think about it as, okay, if I need to know something about this error, is it a temporary error? We'll assert, does it fit the temporary interface, which you get from net.con, or you can define yourself. And that leads to much loosely coupled way of error handling. I don't know anything about whether this error happened. I don't know whether it happened in my direct caller or whether it happened 100 stack frames down. Something happened. I'm going to clean up and hand the error back to the top. So that's kind of like a way for designing Go programs that just deal with errors in that kind of fail fast kind of way. You don't, at every stage, you're not trying to, something went wrong. I'm going to look at that error and see if it matches a dozen of the kinds that I know about, and then in those particular cases, I'm going to retry it, or I'm going to adjust some timer and then do it again. No, just blow up. Just blow up. Give it back to the person above you. Maybe they know how to do it. Just hand the error back. Fail early, fail fast, because we know that's the way to write reliable software. You know, that this idea of crash only software. If an error happens, just quit. Something will restart you. Try again. So that's kind of one part.
In the case of the is temporary check, I know in your talk you kind of brought that up, but do you advocate that if it's temporary, people do some kind of exponential back off with some back pressure to eventually fail out, or are you kind of advocating just always return and pass up the chain and handle it at the highest level possible?
It's always a trade-off. I think in the places where your code does actually know it's dealing with the network. So this is to come back to the idea of you want to have modular design, and if the way that your modules interact with each other are interfaces rather than concrete types. In the case that your code does know it's dealing with the network, like you're actually writing a HTTP server, or you're writing the SSH package or something like that, something that will most of the time actually work over the network. You have this implicit knowledge that when a particular caller operation does fail, it could be because DNS just flaked out, or the network just flapped, or something like that. Oftentimes, when you're working in this, thing you're passed by another package is just a read-write closer. You don't know where that came from. Could be a buffer, could be a file on disk, could be anything. So it really depends on what is the goal of your package, and to take that responsibility and just wrap up. So you can imagine that the HTTP package knows a lot about the network. It knows that there's even things that we're trying to do in 1.8 to retry HTTP errors, if HTTP operations, if we think that they're safe to do so. Like it's a GET request, it didn't have a body, there was a temporary error trying to make the connection. Maybe in that circumstance, you can you can retry. But all those kind of caveats mean that you know a lot about the environment that package is operating in. I think in general, you don't know, you don't have that kind of the kind of visibility to how your package is working in. Many times, perhaps you shouldn't. Perhaps you should try and treat them more like black boxes, because that makes them easier to just clip together. There are less implicit agreements between code. They have to be they have to be explicit, or they're just opaque.
I guess that makes sense, because even if you think about it from the network concept, I mean, what are you doing, right? Some temporary error may have occurred, but you can't guarantee idempotence, right? So you could retry, but that may cause some undesired effect on the other side because it half completed or something like that. So yeah, I guess I can kind of see how retrying is always hard. You really have to understand what the system is doing and potentially check state and make sure that something didn't get half committed before retrying.
Exactly. So in those situations, it shouldn't be so easy to just blithely just put it in a retry loop. Like, you perhaps want to think about how this operation failed, and that means that you need to know then very intimately about all the parts of the code downstream for you, which means a lot more coupling. You have a lot more knowledge of the components that you're building on top of. That's certainly, there are cases to do that. I think they're less widespread than people think. And in general, you want to try and compose your programs out of smaller pieces. Like, to give an example, the SSH package, which is obviously built on top of networking and SSH and public keys and SSH agents, the interfaces that those types implement are just your usual read-write closer. We worked really hard to make the con interface and the session interface look pretty much like a read-write closer, or a similar thing that you get from OS exec. People don't expect OS exec failures to be retriable, so we don't really expose those either. So that's all from the point of view of building packages that interoperate at a very, very high level. They don't know a lot about each other apart from the interfaces. There's a separate part of error handling, which is when error does happen, how do you tell the developer or the operations person, or that what I was saying earlier, you just kind of wave your hands and say, I'm just going to give the error back to the person above me, the code above me. It'll figure out what to do. Eventually you're going to reach the top of your function or the main handler of your web server or whatever it is, and that cost is going to come due. You're going to have to figure out what happened. And in that case, you want to get as much information about the error that happened. You want to encode as much information as you can. Preferably, you want to get a stack trace or something to point you to where the error actually occurred. Because as a developer, I'm going to get a bug report, and if it just says failed to do request IOEOF, where did that come from? Where did that come from? So that the second part of error handling is using the fact that the error is a value, and we've just talked about, from the caller's point of view, just making it opaque, just making it an error happened. You don't know anything more than that. Then we can use this fact and we can stick extra information into it. We can, for a long time, the tradition has been use fumt error f, put some little prefix, and then print out the error, and then kind of annotate the error all the way up, so you get this kind of string that's growing with a little bit on the front every time. That's been a pattern we've seen in the standard library a lot. Donovan and Kernighan talk about it in their book. There's a lot of Go code written out there. If error not equal nil, return fumt error f, some description that says what happened, and then the text of the error. And that's good, because at the top you get at least the kind of, Roger used to call them breadcrumbs of, this failed because this failed, colon because this failed, colon because this failed. And you can kind of grep for those little individual strings and kind of manually construct a stack trace of where you were in that code. And that's good, but it has problems that there are cases, as as few as they are, and as many as I would prefer that weren't, in the standard library, we do actually want to check for a specific value. IOEF is the super example of this. Any IO reader must return IOEF. It can't return, read failed : IOEF. It must return exactly that value of IO.EOF. We're actually checking for equality there. So in certain cases, you can't do this annotation because taking IOEF, printing its string out, appending it to another string, and then returning an entirely different value from func to errorf gives you something which doesn't compare, and you can't strip off that prefix anymore because you've forever damaged it. So if we're talking about using the error value to annotate like extra information, some kind of message or a stack trace or something like that, it has to be undoable. And again, this is not my work in this area is very small. It's certainly not unique. There's a lot of work that I stand on, which this idea of, okay, so if we have an error, let's give it a method. Let's give it a method that lets you get the underlying error. So if we're stacking them one on top of another, let's have a method that we can undo this stacking, so that if we do need this behavior of saying, is this IOEOF? Or for example, if you use OS is not exist, that knows about a certain bunch of types from syscall, from Windows. There's a few other ones that it knows specifically to check, and says, I know how to interpret these error types, and I know how to look at them and say, is this actually caused by a file not found? So you need to be able to, whatever wrapping you do to add context, add a stack frame, add a message, you need to be able to undo that, because there are cases where you need to extract the error value because that's the way the code goes.
Right. And I mean, there's cases where we've seen where people have masked the Sentinel error values based on the type that they're returning in their error too. So relying on those kind of Sentinel error values and stuff becomes problematic. But so the nice thing I like about this approach too is the other pattern we've seen people trying to solve these same problems with is tagged logging, right? But that only helps in the log messages that are going out. That doesn't help the callers that the messages are being passed back up the stack to.
Oh, this comes into my other big rant, which is only handle the error once. And handle means basically I've inspected the error value. If error not equal to nil, that's your inspection. I've looked at it, and then you get to make exactly one decision. And that decision could be to log the message that you've handled it, like you've written it out, and so therefore the error is handled. You don't need to return it to the caller. Now, what are some cases you might log it? Say you're like searching in a search path. You're looking for a particular file, and it's not in your home directory. It's not in the shared directory. Is it in the system one? So you're not going to bail out on that first time around, because it's not in your home directory. You're going to look in the shared location, then you're going to look in the system location. So you check the error, and you might either say, okay, it wasn't found there, but I have two more search paths to look. So the error is handled at that point. What I see a lot is at every level in the call stack, if error not equal to nil, I'm going to write out, log, some error happened, and then return that error to the caller. So that means, however much you've applied this pattern all the way in your code, you're going to get 10 or 15 different log messages basically telling you the same thing. Error happened, failed, error happened, couldn't open file, error happened, couldn't parse JSON. And then right at the top of your handler or your main function, you're just going to get the raw error with no stack trace and no context. And logging kind of happens externally, like it's written out to standard out, or it happens through some log shipping, and the actual program logic of handling that failure case operates in an entirely different universe. So not only are you generating a bunch of log messages, but the thing that you get back at the top of your program has no context. It has no hook to any of that log context that you were sending out to logging. So I strongly advocate, if there is an error, then just return it to the caller. And the errors package with the wrap method gives you the ability for that little piece of log context that you're going to call log.errorf. Just put that in the error message in the error itself, errors.wrap with that message text, and return that to the caller. So you get You get all those annotations which were previously kind of sent out to the log file via this kind of side channel are now available at the top when you're going to print out or analyze that error or log it into a file, or quit the program because the error happened. You have all that context there for the operator or the developer to figure out what happened.
I have a question about that. So how does structured logging fit with this philosophy? Which I totally see the point of what you're saying. The repeats, especially if you're not really crafting your logging message strings. But how do you handle, if you want to do structured logging, do you use the dump of the levels, that you accumulated into a value, and that's your log?
So this is probably the most opinionated thing I'm going to say, but I don't see the point in structured logging. Not because I think it's not a useful thing to, rather than just have a free text blob of text. This idea of key value as logging is useful, but I think there are really two consumers of logs. There is the person running the program. I usually say the operator, because I come from an ops background, and in that case, if a program tells me something like this kind of Unix philosophy, if the program tells you something, then it was important. You should pay attention to it. The number of environments I've worked in where you can't look at the log messages without grepping out a bunch of rubbish is a big problem. So if the only things that you log are things that the user needs to take action on, then I don't see a lot of value in investing in a kind of framework for describing keys and values for logs. Now, to be very, very clear, this is my opinion. I don't want to push that onto anybody else. I know there's a lot of people who see a lot of value in structured logging, but for me, looking through this window of like, if you're going to log a line, it's actually something that I need to take action on. Then arguably you should be logging very little, because if there's thousands of lines of output, something has gone terribly, terribly wrong. And if there's thousands of lines of output and nothing has gone wrong, your program is just really chatty, then you've got a much more serious problem. The second persona is obviously the developer, and I keep them separate from the person running the program versus the person debugging the program. And the developer wants all the logging and tracing on. So I think in that case, your structured logging is something that you use in development, and maybe you interpret that to be always print out the file on the line and the function that it was executing in, and maybe some timestamps and things like that. Then yes, that is super useful. But I don't think the two use cases should be conflated. As the operator, I only want programs to output when there's something that I need to do. They shouldn't just tell me that they're still running. They shouldn't just tell me kind of information like, couldn't dial this socket, but I'm retrying. It's okay, don't worry. Like it's not something I need to care about. You shouldn't tell me that. For the developer, yes, you want to turn on all those logging so you can see the retry loop, and you say, well, it always retries 3 times before it does anything. But they're different personas, and so in that kind of worldview, structured logging doesn't seem as useful to me.
Yeah, and I think we had a conversation with Scott Mansfield from Netflix too, and he was talking about how they don't really rely on logs so much as they do counters. They use metrics for everything, so they would count the number of reconnect errors that are occurring and measure that over time, and they could see that there's a clear problem because the number of reconnect attempts is happening at a much higher frequency than usual, and that's when they start kind of digging in. I think the other case where people like structured logging is in distributed application tracing. So I can look for a tag that says, a request ID, and I can get all the logs associated with a given request. But kind of to your point, when you get to large scales, it's really hard to manage all those logs anyway. So you kind of have to find different ways. But I kind of want to roll back a little bit where we talk about trying as the best you can to return upstream. One case that I see a lot of people use logging for in those cases is when you're in kind of like a select loop, right? You're pulling from a channel, something happens, you don't want to return because you're just a parallel work stream. You're running kind of concurrently to the main thread. So you don't want to die out because then you stop processing all messages. And I typically see a lot of logging take place in those types of methods so that people aren't just kind of throwing away the fact that there was an error with some given thing.
Yeah, yeah. So you've got to consider the persona that you're in. Are you in the developer persona? Like I want to observe the operation of this select loop. Like it's one of many that's going on currently. I believe that if I can see kind of get insight into how all these different parts and these different intermeshing parts are moving, I will be able to reconstruct the flow of events later on. That's kind of like the developer persona. The operator persona, like if that was just dumping out information, like I'm going back through the select loop again, what one of n conditions fired, that would make me furious. I've worked in environments in trading companies where we would produce gigabytes and gigabytes of logs per application, and there are many applications running at the time, and all my day was just zipping and unzipping these things and then grabbing out a bunch of stuff that was not useful. I think that the distributed tracing example is a really good counterpoint to my points about structured logging. That actually, yes, that request ID is something you want to thread through, but is that something that needs to be printed out on the console? Like I'm handling this request, or is it just something that goes into in terms of logging? There are definitely exceptions to this case. Audit logs are a great example, probably a perfect example of where structured logging is useful. User ID, in group ID with permissions set, did operation, because you do need in large scale systems and well regulated ones, you do need audit logs. But again, the audit log is not something that the operator sits tailing. It's not something you're going to alert on, like an error happened in the audit log. There are different personas.
So in the same subject, I wanted to ask your opinion, because I see logging and instrumentation of metrics as serving different purposes. For example, I can start tracking how many times a certain request came through, because I usually get 500,000 a day. And if I certainly start getting 200,000, I want to be alerted something is going on. And I want to see those metrics. What is your opinion on instrumenting your code that way with getting metrics out of it?
Yeah, they are absolutely separate things. Logging is for the human. Instrumentation is for the machines, for your monitoring, for your automated alerts, for your hysteresis, your automatic retry, your scaling up, your scaling down. That if you're driving those processes off tailing a log file, you have a serious operational problem. They are separate and independent things.
Yeah, and I think logging too should be something that you should be able to back off of. I've worked on systems commonly where, it's streamed over UDP and stuff. So it's one of those things like you don't want logging to slow down your application because there's some slowdown on the disk, or, things start catastrophically failing because you run out of disk and things like that. So, and I guess it depends on how important your logs are, right? Like if you're doing something for a bank, you probably want every single message. It's probably of grave importance to keep that for audit purposes. But, in other cases, if you're logging requests to your site, if you lose a minute and a half of logs because there was some slowdown there, it's just not the end of the world.
Yeah, there are different use cases, like the audit log, the HTTP request log, if you have to keep them for analytics or fraud detection or something like that. And then there's the log of your actual application code does it tell you every time it speaks to you, does it tell you this is something you need to care about, or is it just telling you things and you're like, I see that error all the time. Like my rule of thumb is, if to work on an application, you have to get out grep to filter out a bunch of stuff which is not important to you. That is the problem, is that you're logging too much and that logging is of not enough value. And this is completely separate from the audit log, which has to happen for every action, the HTTP request that has to happen for analytics and fraud purposes, or the metrics, which are how you monitor the health of your system.
It's hard because there's no cardinal rule, right? It's just kind of like the other topics we've had here today. It's really kind of looking at your program and determining how important these things are to you. Like, are they a necessity to operate and maintain this application, or are they really just fluff that make you feel comfortable that you could open a log and see that data if you wanted to? And the number of times I've seen applications that are heavy on the logging side and nobody ever looks at the logs is, that's probably the better majority of applications I've worked on. Most of the time you're looking at your metrics dashboards and things like that. It's too hard to go grepping through logs, and especially when you don't have a central logging place for these things, which at high scale also becomes its own problem, because that's another system that can fail when you're kind of doing your distributed logging out to one place, and you have to make the decisions. How worthwhile is that additional complexity to you, and the additional storage to store all these logs and things, or are
Yeah.
you really trying to get a rough state of your application?
And companies that handle that for you, they charge a lot of money. It's very expensive.
Oh yeah.
Those companies love when you throw them just needless logs. There's usually some kind of like per rate charge.
So that there's a strong moral hazard in there for them to not help you become better. They'll just write you a better tool to handle larger volumes of logs. By all means, don't change. Just keep going how you're going.
I think the difficulty is that when you look at a line of code and you're thinking about if something were to go wrong here, you think about all the times that you've tried to debug an application and you didn't have enough information. So I think people err on the side of providing too much information, so just in case they need it. And I mean, I guess there's other ways around it too, aside from logging all the time. Some people will build in ways where they can signal the application to change its verbosity for the logging levels. Some people do canary builds with additional logging in them. There's just a variety of ways you can attack debugging a problem, because the other issue becomes when you have errors. Is it like a systemic issue that like continues to happen and plague the rest of the system, or is it just an anomaly, right? Like you're going to occasionally have bugs that doesn't matter how much logging you put in there, you're probably never going to figure out why that happened. It's just if you can't reproduce it, it's always going to be hard to debug just looking at the log messages that took place. The log messages are really only there to guide you in setting back up the conditions that were taking place when that error occurred.
Exactly. And once that's happened, it's too late. The horse is bolted. So to come, you mentioned errors. To come back to errors, why I think Go is so successful for being a language for writing server software, and that this is really where we're seeing it. I mean, it's branching out into other things as well, but its home territory is server software, is because of the way we do error handling. We don't have exceptions, and perhaps not everyone has grasped this, but every time you type, you might think, oh, geez, if error equals nil, then return nil. I have to return error. I have to type this all the time. That's missing the point. It's making you think about what happens if this operation failed, and you have to do that everywhere, all through Go code, because we don't have exceptions. And we don't have exceptions because to write reliable programs, you have to think about the failure case first. Don't worry about the happy path. Think about what happens when this fails. And I think that is what is making Go really successful for writing server software, because you can't just write the code in this linear, everything's going to work, and that throws clause on the function declaration is going to take care of any problems. We see how the languages with exceptions go for reliability. You don't know if they're going to explode at any point. And as verbose as Go's error handling is, it makes us think about what happens if this fails, literally at every function call, because any function call can fail. And if you don't want that function call to fail, don't return an error. Write it in such a way that it can't return an error by having extra preconditions, or accept the fact that anytime you deal with the real world, the network, the disk, it could fail, and you need to handle that failure right then and there, rather than just waving your hand and saying IO exception will bubble up to someone who knows how to handle it. The best place to handle that failure is right there in that function, right at the point that the error happens.
And if people are really annoyed about doing the if statement all the time to check the errors, they can use your errors package, right? I love it the way you made it so you can just return the error, and if it's no, it's no, and if not, the message is there, and that's it.
Yep.
So I know when I first got into the language, the kind of verbose error handling was kind of annoying too, because I came from languages that had exceptions, and then you start to realize it does make a lot more sense there. But I think it's just a change of viewpoint, right? So it's a half class empty versus half full, right? So we look at it and we're like, wow, this is annoying that I have to keep doing this. But it's much more exciting when we think about the fact that everybody else who's working on this project also has to do this, right? It's kind of like HOA regulations, right? Like it's kind of a pain in the butt, right? Like it's annoying because you don't want to have to follow the rules, but it makes everybody else follow the rules, you know?
Well, I think another corollary to that is the idea of interfaces in Go. I was thinking through this today, and I think there's a good parallel between the way you think about interfaces in Go and the way you handle errors in Go versus other languages. You know, with Go interfaces, you're modeling behavior, and you don't have to think very hard about that inheritance chain and which abstract classes to create above them. You know, I did a lot of Java and C# and Ruby and all of that object-oriented inheritance. There is a big cognitive load to that. And just using embedding and composition in Go feels so light and so much better, but it's hard for people who come from object-oriented languages to catch that feeling. So again, it's one of those things where it takes everybody some time to adjust to the new features that they're not used to before they can embrace them.
I agree, and this is really the open question that I had from my talk. Is that like the every episode of this podcast, every time you interview somebody, everyone at some point in the podcast says, "Oh, geez, you should see my first code. I used so many channels, I did them wrong." And it's like everyone knows that lesson now. Like anyone who's become a successful Go developer is like, "Whoa, far too many channels. I went overboard there." But that's how can we find don't use too many channels is not actionable to a new Go developer. They're like, "What are you talking about? This is why I learned this language. Apparently, concurrency is a really important thing. Why shouldn't I use channels?" So it becomes really subjective and not particularly useful to say, "Oh, be careful! Don't use too many channels." Where is the design language that says where is a channel appropriate, where is it not? Those kind of things I think are missing in the general discourse of Go, or if not missing, not emphasized. It's not the things that we talk about. We focus on speed or static compilation or cross compilation or other things like that, which are equally good, but they're kind of missing the wood for the trees. Like where's the kind of Eric talked about it, the way that in the Ruby community there's this focus on design. People would talk about a language design always. That was the kind of things that you would talk about at conferences. Where is that language, that discourse in Go? That's really the open question from my talk, I think.
I'm very glad to say that I'm starting to see a major shift towards that conversation with you and Ben Johnson and Matt Ryer. I wanted to mention Matt Ryer wrote a blog post about his talk also at Golang UK about talking about check your errors first and then do the happy path, just like you're saying to do. And this is just goes to that concept of put a guard in your method, right? It's a design concept. Going back to what you were saying about this conversation about design, when I started doing Go and when I was meeting people who were experts, I would ask, "How did you learn?" And try and error would be the answer. And on again, people would say try and error. And now I see that people are thinking, well, let's not subject people through try and error anymore. Katrina's talk at GopherCon in Denver had a lot to do with this concept of let's pave the path for people to jump in and not go through the hassle of trial and error. Let's have educational material, and now a lot of people are coming out and talking about design. I think I sense that there is a shift, and I think that's very, very positive.
Yeah, Katrina's talk was fantastic, and the thing that we should all on this podcast remember is that we are the success story. We're the ones that didn't quit. We're the ones that didn't get so lost that we made such a mistake, such a mess, and we couldn't figure out, and we just gave up. Like we're actually the ones that figured out how to write successful Go code. And Katrina's talk is really important because, as she said, as a beginner, you don't have that. There's a phrase, hindsight is 20/20. Like we're all looking back at our experience and saying, "Oh, geez, it was hard to learn, but we got through somehow." Like put yourself back into the mind of the beginner, and you have no concept of right or wrong. You don't know when you're writing good code or bad code. You don't know when you're doing you're bringing knowledge from another language, or you're just learning this from scratch. And is this good or bad? Am I having a hard time writing this program because I'm fighting against the language, or because I'm actually making a mistake? Like with that, as a beginner, you have no context to judge yourself, to judge your progress like that. So Trinity Talk was really important to remind us all of we are the success story. We're the ones who persevered and learnt learnt the language, either through trial and error, or just reading the right example at the right time that put us on a successful path. But we shouldn't consider that with enough time anyone can do that, because a lot of people are unsuccessful and they give up halfway through.
Yeah, good point.
So I think we are actually about over time. So I think we're going to skip over kind of talking about news and projects this episode, as much as we would love to go forever. Can we do like a 12-hour podcast?
With Dave, I think we can, yeah.
So I think we can skip into Free Software Friday, and then we'll kind of close out the show. As always, Brian, you want to kick this thing off?
I do. I spent a whole lot of time playing with rsync this week, and it's old school Unix tools, but I just can't live without rsync. So big shout out to the people who keep rsync fast and awesome and safe. I love rsync. Thank you.
I think that is Jeremy Allison. Is that his name? It's the same people that make Samba make rsync. Maybe I'm remembering it completely wrong, but there is a strong correlation between the two, I think. But yeah, rsync, using rsync and SSH, you can pretty much move the world.
Yeah, and I think I did this week.
Do you want me to go next? I have one.
Sure.
Yes.
So somebody gave a shout out to AG a couple of weeks ago, I think, on the podcast.
That was me.
I have one better, because it's called PT, the Platinum Searcher, and it's written by a Japanese gopher. I'll put the name up. I'll put the link in the show notes. But yeah, PT, it's way better than ACK, way better than AG. I use it every single day. I'm not a big one for editor integrations. I have a very Spartan environment, and so it's for me, my entire day is just PT, some piece of text, find the line, go and edit it.
I am so looking forward to installing that. With these endorsements, I use ACK all the time. Also, not on my editor, just on the terminal. And this is sounding like what you're saying is better. And by the description, I'm just dying to try it.
Well, has all the features of ACK and AG of skipping over temporary files and .gits and things like that, but it's written in Go.
I'm trying to think of who it was too. Somebody had just mentioned, I think it was Harold something Ringwald, maybe, in the Go Time FM Slack just before we got on the show, had pointed that out to me too. Like, have you seen this? So I definitely need to install it. So you said it's basically feature compatible with the Silver Searcher?
Pretty much. I mean, I don't know what the features are. Like, I just use PT. My two requirements, like PT and PT minus L. So minus L just gives you the names, and you pipe them through Vim and edit your files. But yeah, written by Monochrome Gan, Japanese gopher. I saw a presentation on this 2014, I think it was. The first time I went to GoCon in Japan.
That's awesome. Plus, we can contribute when we find new usage. But I probably have a similar workflow to you. I basically AG a directory looking for what I'm looking for and then just open it in Vim. I don't do a whole lot of editor integrations and stuff like that. I'm just pretty comfortable with having my editor open and a shell.
I just installed this and it's beautiful.
You're ahead of us. So how about you, Carlicia?
Well, so I recently got a job doing Go full time, and I was working on a new project and going through the phase of, defining and designing. And recently I got full on coding. And my shout out today, we've mentioned it before, is SourceGraph. I cannot tell you how much faster I grok things. If I'm on GitHub, I don't want to download everything to my local machine and just search on my local machine. I could do that, but it's so much faster to just go. I'm on GitHub looking at a library and I'm browsing through the codes and I have SourceGraph guiding me through, just popping up the descriptions. And if I want to go deeper, I just click on the link and I'm there. It's been amazing. I've learned 100 times faster, just like learning what I'm looking at and also learning Go at the same time, because, of course I see the patterns. And another shout out is just Go itself. I love that the Go code that I see on people's libraries they look exactly pretty much the same as the Go code that I'm writing. Is the consistency is amazing. Makes life so much better.
Awesome. So mine this week is a little off, but I haven't been using a lot of new programming tools over the past couple of weeks, and I don't think everybody wants to keep hearing new stuff or old stuff. So I'm going to shout out to ASCII Doctor, which is asciidoctor.org. And typically I'm a Markdown person, but I haven't found a really good tool set for being able to do like table of contents and things like that for Markdown. So ASCII Doctor is similar to Markdown. It uses ASCII Doc, and then it kind of behind the scenes can do DocBook and things. So it can generate PDFs with like linkable table of contents, and you can do kind of like little sidebars and annotations and stuff. It has source code highlighting and stuff in it. So it's really awesome for doing documentation, especially with code and stuff involved.
Nice.
Yeah, I use it all the time. I actually write all my talks long form, like I actually write out everything I want to say. And I generally do before I then transpose it into like Keynote or something like that. For one, like I need to know how many words I've got, and the Keynote won't tell you that. So like I tend to write out the whole thing long form, and I've taken to writing in ASCII Doctor so that I can then turn it into HTML and send a link to people. And that for me, that's so much better than using a Google Doc, because to use a Google Doc, you've got to be online, whereas this is just a text file. You can edit it wherever you are.
Nice.
And we can just use Vim. Nice little guard file, updates the PDF alongside of it. And then I get to give a second shout out to Afrin for preventing me from sniffling this whole show.
Is that open source?
No, it's not open source. And you probably have to show ID at the counter of the pharmacy to get it these days.
Really? Wow.
The ingredients are listed on the back. I mean, that's somewhat open source, right? I guess the algorithm to combine them, it does not exist.
Yeah, that reminded me of Katrina's talk again. You have ingredients, but you don't know how to put it together.
The correct mixture ratio.
Yeah.
So, all right. So as much as I would love to continue on, especially having Dave on the show, we've had a lot of interesting conversations, and I think way more that could be had. I think we are like way over time. So this will be a nice long episode. So I definitely want to thank everybody who's on the show today, everybody who's listening, everybody who will be listening to the show when we drop it live. Big shout out to our sponsor, Backtrace. And if you aren't subscribed already, you can subscribe at gotime.fm. We should have an upcoming newsletter. We are GoTime FM on Twitter and GoTimeFM/ping on GitHub if you want to submit yourself or suggestions for guests for the show or questions. And I think that's it. With that said, everybody, goodbye.
Hey, thanks for getting up so early, Dave.
Not a problem. Thanks for having me.
Thank you so much, David.